Hi, everyone. Thank you for inviting me, Stephanie and Vincent. I'm very happy to be here today and um, share our work on integrating features from multiple modalities for trial deception detection. And before talking about this project, I would like to recognize that this work is in collaboration with Radha, Nihalsha, Mohammed Abulian, and Mihai Burso. And we worked on this a couple of years ago, but I think it is still very relevant because we are still trying to improve our system and trying to get new findings. So I would like to start with the motivation for this work. And this is that hearings from witnesses and defendants play a crucial role with reaching court trial decisions. And as you may know, consequences of falsely accusing the innocent and freeing the guilty can be severe. And as an example, there are many statistics. For instance, currently in the US, there is a large number of individuals that have been declared guilty by mistake or they are under some exoneration process. And traditionally, law enforcement has used methods such as the polygraph. And these methods are impractical because they require close contact and is also prone to error. And of course, there is also the issue of humans, their bias. So our main goal is we pursue two research objectives. The first one is implementing accurate and effective computational methods to evaluate the honesty of provided testimonies in trials that can assist the decision-making process. And we want to explore and to integrate multiple modalities for detecting deception and real-life data. So something to mention before describing more about the system is why we need real deception data sets. So first, as you might know, most of deception data is usually collected from human contributors. This is in a lab setting or via crowdsourcing. However, one big challenge is that subjects in labs might not be emotionally aroused, as they might lack motivation or penalty for their participation. And of course, annotating observed deception is challenging and hard to scale up. Now, we wanted to contribute to the fact that there were a scarcity of this type of datasets, and we built a dataset consisting of 121 deceptive and truthful video clips from real public trials. And we also built the multimodal system that jointly uses verbal and visual modalities to automatically detect the presence of deception. And our idea with this system is to actually offer support to the decision-making process, not to be the solely source of detecting deception. So what we did was collect a data set from public sources. So we look for public famous trials, and this includes statements from both suspects and witnesses. And we also look at videos from exonerations. Our dataset was labeled in a way that relies on the verdict or exoneration status. That means if we find out the decision of the trial is being guilty, then people were deceptive, and vice versa. Same thing with videos that were talking about witnesses that were defending guilty individuals. They were labeled as deceptive, and witnesses who were defending individuals who were not guilty were labeled as truthful. And in our data set, we have 21 unique male and 35 unique 21 unique female and 35 unique male speakers. And their ages ranging between 16 to 60 years. And we have an almost balanced distribution between deceptive and truthful videos. And the length of each video is an average 28 seconds. We started by transcribing these videos. And for that, we used Mechanical Turk, and those transcriptions were manually verified. We had a large set of 8K words in our data set, with a 66 word on average per transcript. And here's a sample a statement for a deceptive video. And I'll give you a couple of seconds to read it. So basically, someone who's denying their participation in a murder. Um, so what we try to do is to look at whether the verbal and visual information will give a cue into the deception in these trials. So for verbal features, we look at very simple features, one of them being unigrams, which is the number of unique words in the transcript, and also bigrams, which is the number of unique words pairs in the document. Um, and then we examine a couple of visual features. These visual features were manually annotated. So we have a team of annotators who did label each of these videos and assign it after those gesture labels per each frame. Per each video. And we look at several aspects. For instance, we look at eyebrow movement. We look, for instance, at eye openness, mouth openness, the overall face expression, and also hand movement, whether people were using one hand, both hands, or were they making some kind of gestures with the hands. For instance, moving the hands to the left, perhaps any complex movement. And this annotation was done with something called the mnemonic coding system, which is a coding system that has been used for multimodal annotation. And this annotation was done by 3 annotators who independently label each of the videos. And we obtained a very reasonable agreement over the different types of gestures in this data set with kappa scores of to 56%. Now, we started with examining what was the relation between these different gestures and the deceptive and truthful labels. And we find that there were some differences in the way these gestures were distributed across the labels. For instance, we found that, and some of them were significant here. I'm including the error bars in this graph. So for instance, we found that truthful individuals actually do more eyebrow raising than individuals who were deceptive. Similarly, truthful individuals had their open mouth more times and also repeatedly shake their heads. And on the other hand, we had people who were deceiving, scowling more, gazing to the interlocutor. This last finding was interesting because usually we see that gazing somehow hints trust or truthfulness, but not in this case. So we conducted a couple of learning experiments where we used these different features individually and also in combination. And here we use a decision tree classifier with the using also cross validation. So we had a system that's run using unigrams only, diagrams only, facial displays, and hand gestures, and also the combinations. And we observed that in most cases, well, for instance, for the verbal information, unigrams did well in the sense that they were above the baseline, which was almost random. And then the best indicator of deception were the facial displays. And interestingly, we observed that when we combine features from both sources, this is language and gestures, we obtain the highest performance, which in our case was 75%. So we wanted to look a bit more into the model to see whether certain features were more indicators indicating of deception. So we identified the 5 most predictive features, and we found that those are the presence of frowning, eyebrow raising, head side turn, lip corners up, lips protruded, lips retracted. So all this information and facial expressions is actually very telling about deception. And finally, we did a human performance study where we tested human ability to identify deceit with exposed to different modalities. And this was to confirm whether multimodal systems have a benefit over human performance. So we have three annotators who went through the different video clips and were shown one modality at a time. So they were shown a text only, audio only, the silent video, and also the full video. And not surprisingly, it happened that people who were shown the full video got better performance at detecting lies. However, some of the poorest results were good silent video where no cues of words and only expressions were available. However, if you see our system did very well when using silent video as compared to humans. So in most cases, um, our system actually overperforms humans for this task, either using text or silent video or the full video. So just to describe a summary and to give some time to answer questions, just I will give you some concluding remarks. First, we introduced a new deception data set that cover recordings for public real trials, and we analyzed which visual behaviors are associated or are related to trial deception. And we built a multimodal deception classifiers with accuracy up to 75%. And we found that in a human study, our automatic system outperforms human with a relative performance improvement of up to 51%. Um, and albeit, I just wanted to mention that the dataset is available in our downloads page. So I will be happy to take any questions.